Okay, let's do a little bit of cleanup. So we're going to get rid of the code that we no longer need, this definition of pi and these. And here we can add a comment that if we don't have it, we get mpi undeclared. Let's also add explanation that fixed means displaying digits after the floating point, and default precision is to display 6 digits. So we comment out set precision, we're going to get just 6 digits. And let's go back to our discussion about radians. And first of all, we compute the circumference of a circle as its diameter times pi, right? Or 2 times radius times pi. And the entire circle over here is 360 degrees. So then we can rewrite this to get the size of the radius measured in degrees. And here, this is not C++, this is just a conventional fraction notation. And this formula gives us the answer how many degrees on this sector fit here if the length of this sector right here is the same as 1 radius. And it's like the radius measured in degrees. How many degrees correspond to the size of the radius? And of course we can simplify this fraction, and this angle measured in degrees is called a radian. So this angle right here is the angle of 1 radian, and it can be computed as 180 divided by pi. And so on the left side we have the degrees, but on the right side we would like to call it a radian. So this is like to add the corresponding unit of measurement here is that this is basically 1 radian. So now we have the relationship between the degrees and 1 radian. And then from here we can derive our formulas, which is basically conversion between the degrees and radians. For example, we could write that 1 radian is this many degrees. So okay, I'll now save this and run this code. And it prints that 1 radian is like 57.3 degrees. Let's lower this precision a little bit. We can set precision just to the 2 digits. Build and run again. So I'm just showing you a shorter version of the output. So this angle right here is close to 60 degrees. And so this shape here is of course forming isosceles triangle, but it's pretty close to equilateral triangle, which has like 60-degree angles everywhere. So it's important just to remember that roughly it's 57 degrees. And in the code typically you get inputs specified in degrees and outputs displayed also in degrees, but internally we must perform our computations in radians, because that's what math library functions are expecting us to provide. But if you have to debug code related to formulas involving these conversions between degrees and radians, it's pretty important to have this kind of rough idea how big the radian is with respect to the degree, which is sort of like really small. So it's just a very small angle. 1 degree is like this, just a little wedge like this, whereas the radian is close to 60 degrees, or 57.3. Okay, so let's try using the radians in our code, and we can try these lines to display sine and cosine of 30 degrees. So just copy this code and paste it here. I'll add standard output, namespace name. Let's run this code. Oh, and we also have to change the pi here and here. Run, and this is sine and cosine of 30 degrees. And of course, in order to be able to complete this calculation, we take our degrees specified as a double value, and we need to convert them to radians. So I'm just using this formula directly in the argument of this sine function, which of course is included by CMath header. Similarly, we're doing conversion to radians before calling cosine.